Hi, everyone. Welcome back. Today, I'm going to talk about confidence intervals. So, given the following statement, it says here a poll of dentists concludes 75% of dentists suggest using ice cream toothpaste. These results are accurate within plus or minus 5%, 9 times out of 10. So, what does that mean? Here it says to rewrite the statement using confidence intervals. So, what this means is what? Well, here it says there's 75% of dentists agree, plus or minus 5% either way, right? So 70% to 80%, right? And this is 9 times out of 10. So this is with 90% confidence, right? 90% here, okay? And so therefore, how can we rewrite this using confidence intervals? We could say that there is a 90% probability, or that's maybe not the best wording. We are 90% confident that between 70% and 80% of dentists suggest ice cream toothpaste, right? Because that's essentially what this is saying using our confidence intervals. We spoke a little bit about confidence intervals last time, but this time I want to go into a bit more detail of what I mean by confidence intervals. So let's talk about confidence intervals when the population mean is known. So a 1 minus alpha, or 1 minus alpha times 100 confidence interval for mu, given a population standard deviation, sigma, and a sample size n with a sample mean of x bar can be represented this way. That x bar minus our z score is less than mu, which is less than x bar plus that z score, right? So basically we're going to add and subtract from our sample mean that z score that we found in order to get that confidence. And so that's how the confidence interval can be represented here. Now let's give an example of this. The example says a car oil manufacturer finds the number of kilometers a car is driven before an oil change is needed has a standard deviation of 700 kilometers. 36 cars are tested to measure the number of kilometers a car has driven before it needs an oil change. And the mean distance is calculated to be 6,400 kilometers. Find a 90% confidence interval for the actual mean distance for the time before an oil change is needed. So first of all, let's write out what we're given here. I think that's probably the best first step here. We know the standard deviation is 700 kilometers because they told us that in the question. N is equal to 36, right? It says 36 cars are tested, so that means N is 36. And then X bar is equal to 6,400 kilometers, right? Because when we took the sample mean of those 36 cars, it was found to be 6,400 kilometers on average that it takes before the car needs that oil change. Okay, so we would like to get a 90% confidence interval. Okay, so let's go and find that. So therefore, we would like to do 6,400 minus the Z score of 10% over 2, so 0.1 over 2. And that's going to be less 700 alpha over 2, 700 over root 36, less than mu, less than 6, 400 plus that same thing. Okay. So next thing I want to find is what is the z-score of 0.1 over 2? Well, that's going to be the same as the z-score. And actually, I want to talk about what this means exactly. What does this mean, 0.1 over 2? Well, what I mean by that is that 90% of this area must be covered. All we must leave out is this little bit on the top and this little bit on the bottom, right? And so I would like to know how we are going to do that exactly, right? How are we exactly going to leave out that little bit on the top and that little bit on the bottom, right? Because this isn't part of our 68, 95, 98.7. This is separate from that. Okay, and so what I'm going to do, therefore, is let's figure out how we can get 90% in there. So what I'm going to do in that case is I'm going to go to my table, and this time instead of looking on the edges of the table for the z-scores, I'm going to look in the middle of the table for the probabilities. I would like to know what probability I'm going to end up getting if I would like 90% in the middle. Now, that might be a little bit of a tricky one because the table entry shows us, everything below it, right? So, what we're actually looking for first is 95, right? We're looking for 95% for all of this. And then we're looking for 95%, which is going the other way for all of this to get 90% in the middle. So let's look for those numbers. We're looking for 90, 95, right? For 95 for all this. And then we're looking for 5% so we can get rid of this last part and have 90 be in our middle, right? So let's first look for 95%. Let's look. 95.54, 95.64, 95.91. Nope, that's the wrong direction. 94 point stuff. Haha, right here. Right here, it's between 1.64 and 1.65. 1.64 to 1.65. Okay, right? These two together. So we could say 1.645. There we go. Now, what about 5%? What if we look for 5%? What are we going to get? Let's do that. Let's look for 5%, so 0.05 or something very close to it. Nope. Let's see, 0.5. Here we go. Haha. This is the same thing, right? It's just negative form. Negative 1.645, right? So in this case, in this situation, 1.645 and negative 1.645 are going to be our answers, right? That's what we're going to end up going with here. So let's do that. Let's go ahead and plug those values in. Okay, so let's go back and let's do it. Okay, so here we have 6,400 minus 1.645 times 700 over root 36 is less than mu is less than 6,400 plus 1.645 700 over root 36. And then we've just got to find the answers there by simplifying. And if we do that, we're going to get 6,400 minus 191.92. 6,400 plus 191.92. And then we're going to end up with 6,208.8 and 6,591.92. So therefore, what can we conclude from this confidence interval? We know that the manufacturer can be 90% confident that the actual mean is going to be between these terms, right? The actual mean is going to be between 6,208.8 and 6,591.92 kilometers. Okay, 0.92 kilometers. So there we have it. Right now we know that, most likely with 90% confidence that, it's going to be between that number of kilometers before the car needs an oil change once again. All right, very good. Let's move on to confidence intervals for population portions, because this was one where we had a sample where we had 36 cars tested and to measure. In this case, let's talk about population one. So here it says for many polls, the population is not known, right? Oftentimes we'll only poll some. And therefore, we're going to let P equal to approximately P hat, which is our approximation, and Q equal to 1 minus P hat, where P hat is the proportion in the sample. An estimated confidence interval can be represented this way. So again, this is basically the same thing, except that look, we've replaced, instead of having X bar, we have P hat, right? And instead of standard deviation over root n, we now have root PQ time over root n. And so these are very, very similar equations. It's something I want to point out to you here. These are extremely similar. Okay, so here's another example. It says here, in a poll of 400 students in a high school, 72 students are found to have exactly 5 letters in their name, a 95% confidence level for the portion of students who have exactly 5 letters in their name. So let's find it. So we know that out of 400 high school students, P hat is going to be equal to 72 out of 400, which is 0.18. And therefore, 1 minus P hat, which is going to be Q hat, is equal to 0.82. Okay, and we want a 95% confidence interval. So therefore, alpha is going to be 0.05 or 5%, whichever you'd prefer. Now, we also know that Z alpha over 2 in this case would be Z of, let's see, 0.025. So this one is going to, in this case, we're going to have to look at for 0.05. Okay, so what we want is 95% confidence. So that means that we would like to figure it out for 97.5, where that is on the probability scale, and also 2.5, right? For the same reasons as the previous example. So let's go back a few pages here, and let's find out where we have 97.5 in our table. Okay, so let's look for 97.5, and it's right here. It's at 1.96. And then if we look for 2.5, that'll also be, that'll be at 1.96 again, except the negative version of 1.96, or at least it should be. So let's see, is that negative 1.96? It is indeed. Okay, perfect. So 1.96, therefore, is going to be our answer there. So this is 1.96. Okay, so now we can do it. 0.18 minus 1.96 times the square root of 0.18, 0.82 over root 400, which is less than P, which is less than 0.18 plus 1.96, root of 0.18, 0.82. Oh, we're losing room there, but that's okay. Root 400. Okay. So that is going to be equal to what? Let's calculate this here. We're going to end up with 0.18 minus 0.037, 0.18 plus 0.037, which is going to be 0.143, 217. Okay, so what we can say here in this case is that with 95% confidence, the poll shows that the proportion of students with 5-letter names is between 0.143 and 0.217, right? Or between 14.3% and 21.7%. And so that's our approximation for cases like this. All right, well, that concludes not only this lesson, not only this unit, but that concludes this course. So, congratulations if you've made it to this point on making it to this point in the course. Best of luck on your test and your final exam, and we'll see you for the next course. Bye, everyone.